Hi, my name's Jonathan. Welcome to Crash Course Principles of Engineering, and today we'll be talking about projectile motion. Projectile motion is anything that is thrown or shot out of anything else that has airtime at some point between it being fired and it landing, and during that time it is affected by gravity and air resistance and anything else such as that. And gravity has constant acceleration, and if you want to look at it in meter sense, it is negative 9.8 meters per second, or in standard sense, it is negative 32 feet per second. And just as a forewarning, they will ask, most of the time you will be asked for the negative 9.8 meters per second, since that is the international standard, but you will see the negative 32 feet per second here and there. And like I said, projectile motion is anything thrown or shot from anything else, and that would involve angles. And if the angle is 90, which is straight up and down, the initial velocity of you either shooting it or throwing it should be the final velocity of it landing at the same level where you either shot or threw it. So let's say I threw a ball at 3.2 meters per second. It goes up and it comes down, and I catch it at the same level off the ground. I should catch the ball at it with it having 3.2 meters per second, except it will be negative since it's coming down. With projectile motion, there's an angle, like I said, and with an angle, there's always an x component and an y component, and to find that, you would either do an sine or cosine of the initial velocity, which would give you the initial velocity in the x or y sense. The x component of the initial velocity is always staying the same. The y component will change due to gravity pulling on the object. For the principles of engineering, there is a couple of formulas that you need to remember, and the first one is to find initial velocity. Initial velocity can be found through the square root of negative of the gravitational constant, which is negative already, so it would make it positive, but times the final range, divide that by the sine of the angle shot times 2. So it will look basically something like this. And the initial velocity, so I picked a random problem and I chose the 9.8 meters per second times the final range, which is 3.8, which is what I chose, meters. And if you choose a specific measurement like 9.8 or 32 feet, the subsequent measurements being put in that formula will have to be corresponding to either feet or meters. So just be on the lookout for that. And then, so back to the problem, times the sine of 45 and times 2. So 9.8 times 3.8 is 37.24, and 45 times 2 is obviously 90, but the sine of 90 is actually 1, so 37.24 will stay the same, and you take the square root of that and you will get 6.102 meters per second. Now, the second formula that you will get is to find the final range. And to find that, you need the initial velocity squared, don't forget the squaring it, times the sine of the angle shot, divided by the negative of the gravitational constant. So to check on my problem, which is initial velocity is 6.102 squared, which is what we found in the previous equation. put the sine of the angle of 45 times 2, which is 90, divided by 9.8, and 6.102 squared times the sine of 90, which is 1, is 37.234404 divided by 9.8, and the final range you get will be, well, for me, is 3.79 meters, which is pretty close to 3.8 meters of what I started with. And the third and final formula, has to do with finding the angle of the object being shot. And to find the angle, you need to take the reverse sign of the negative of the gravitational constant times the range. Divide that by the initial velocity squared, and it would look something like this, which is 2 times theta, which is what you would originally put into the other formulas, times the reverse sign of negative gravitational constant times the final range, and divide that by the initial velocity squared. And if you do it for my problem, you would put positive 9.8 times 3.8 meters, divide that by 6.012 squared, and then you would take the reverse sign of that, and you should get 90, and 2 times theta equals 90, so 90 divided by 2 would be 45 degrees, and you should end up with 45 degrees. And that is it for today's video. I will have a nice day.